These 3 microfarad capacitor and 6 microfarad capacitor, they are joined in series. How do you know they are connected in series? Series combination means a single way, there is no branching occurs. If a single way, no branching, then this type of combination is series combination. So these two capacitors, they are in series combination, and the effective capacitance is C is equal to 1 by 1 by C1 plus 1 by C2, that is C1 C2 by C1 plus C2. C1 is how much? 3 microfarad into C2 is 6 microfarad divided by 3 microfarad plus 6 microfarad. So this is coming 18 divided by 9 microfarad, that is 2 microfarad. These 2 microfarad and 1 microfarad, they are connected in parallel. How do you know they are connected in parallel? A point is connected to one plate, this one plate of 2 microfarad and one plate of 1 microfarad, they are connected to the point A by connecting wire. So this plate is connected to A by connecting wire. Similarly, this plate is connected to A by connecting wire. The other plate of this 2 microfarad is connected to B by connecting wire. The other plate of 1 microfarad is connected to B by connecting wire. So these two capacitors are in parallel combination. Then the total or effective capacitance is C is equal to C1 plus C2. C1 is 2 microfarad plus C2 is 1 microfarad. So the result is 3 microfarad. This 3 microfarad and 6 microfarad, they are connected in series. Similarly, 2 microfarad and 2 microfarad, they are connected in series. 2 microfarad and 6 microfarad, they are connected in series. But we cannot say these 3 microfarad, 6 microfarad, 2 microfarad and 6 microfarad are in series. We cannot say, because they will be in series if there is no branching occur. But here is a branching, so that is why this 3 microfarad, 6 microfarad, 2 microfarad, 6 microfarad, they are not connected in series. Similarly, 2 microfarad, 2 microfarad, 2 microfarad, 6 microfarad also are not in series, because here is a branching. If this branching is absent, then this 2 microfarad, 2 microfarad, 2 microfarad, 6 microfarad will be in series. So 3, 6 are in series, 2, 2 are in series, 2, 6 are in series. So these two capacitors, they are in series. The effective capacitance is 2 microfarad. These 2 microfarad and 2 microfarad, they are connected in series. The effective capacitance is 1 microfarad. So the effective circuit is now This is a point, this is 2 microfarad, this is 1 microfarad, this is 2 microfarad, this is 6 microfarad, this is B point. Then these 2 microfarad and 1 microfarad, they are in parallel. So these 2 microfarad and 1 microfarad, they are in parallel. This total is 3 microfarad. So the effective circuit is, this is 3 microfarad, this is 2 microfarad, this is 6 microfarad, this is A, B, this is 3 microfarad, this is 2 microfarad, this is 6 microfarad. The effective capacitance is C equal to 1 by C1 plus 1 by C2 plus 1 by C3. So the result is 1 microfarad. This 3 microfarad, 6 microfarad, they are in series. This 2 microfarad, 2 microfarad, they are in series. This 2 microfarad, 3 microfarad, they are in series. So this 3 microfarad and 6 microfarad, that total is 2 microfarad. This 2 microfarad and 2 microfarad, this total is 1 microfarad. So the equivalent circuit is, this is 2 microfarad, this is 1 microfarad, this is 2 microfarad, this is 3 microfarad, this is B point. So this is 2 microfarad, this is 1 microfarad, this is 2 microfarad, this is 3 microfarad, and here is another capacitor, here is another capacitor, this is 3 microfarad. Between this point and this point, this capacitor, this capacitor, this capacitor are in parallel. How they are parallel? Because this point connected to by the connecting wire to this plate, this point connected to by the connecting wire to this plate, this point is connected by the connecting wire to this plate. Similarly, this point is connected by connecting wire to this plate, this point is connected by connecting wire to this plate, this point is connected by connecting wire to this plate. So this capacitor 2 microfarad, 1 microfarad, 3 microfarad, they are in parallel. Hence the effective circuit is now these three parallel combination, that is 6 microfarad, this is a point, this is A, then next this is 2 microfarad, then this is 3 microfarad, then B point, then the three capacitors are in series, so the effective capacitance is 1 by 6 microfarad plus 1 by 2 microfarad plus 1 by 3 microfarad, so the result is 1 microfarad. These 3, 6 are in series, these 2 are in series, these 6, 3 are in series, hence the effective circuit is this 3, 6, that is 2 microfarad, this 2, that is 1 microfarad, these 6, 3, that is 2 microfarad. So the effective circuit is, this is 2 microfarad, this is 1 microfarad, this is 2 microfarad, a parallel combination of 4 microfarad, this is B point, this is A point, this is 2 microfarad, this is 1 microfarad. These two parallel combination between this point and this point. Similarly, these two capacitors, 2 microfarad and 4 microfarad, they are in parallel combination between this point and this point. So this 2, 1, this is 3 microfarad, this 2, 4 is 6 microfarad, the effective circuit is then P microfarad, 6 microfarad, AB, these 3 and 6 microfarad, they are in series combination, so the effective capacitance is 1 by 3 microfarad plus 1 by 6 microfarad, so the result is 2 microfarad. These three capacitors, they are in parallel combination between A and B. How do you know? This plate is connected to A by connecting wire. This plate is connected to A by connecting wire. This plate is connected to A by connecting wire. Similarly, this plate connected to B by connecting wire. This plate is connected to B by connecting wire. this plate connected to B by connecting wire. So the three capacitors are in parallel. Hence, the effective capacitance is C equal to C1 plus C2 plus C3. So the answer is 11 microfarad. This 3 microfarad and 6 microfarad, they are in series. This total is 2 microfarad. So the circuit is equivalent to, this is 6 microfarad, 6 microfarad, 3 microfarad, this is 4 microfarad, and this is 2 microfarad. This one is 1 microfarad. This is 1 microfarad. This 2 microfarad and 4 microfarad, they are parallel. So the parallel combination is 6 microfarad. So the given circuit is this is 6 microfarad, 6 microfarad, 3 microfarad, this is 1 microfarad, this is 1 microfarad, six microfarad, 6 microfarad, 3 microfarad, then this one is 6 microfarad. This is A point, this is B point. This 3 microfarad and 6 microfarad, they are in series. This total is 2 microfarad. So the given circuit is now equivalent to A point, 6 microfarad. This is 6 microfarad. This is 1 microfarad. This is 1 microfarad. And this is 2 microfarad. 2 microfarad. This is 1 microfarad. This is B point. This 1 microfarad and 2 microfarad, they are in parallel. The effective is 3 microfarad. So the equivalent circuit is A, This is 6 microfarad. This is 1 microfarad. This is 6 microfarad. This is 3 microfarad. This is B point. This 6 microfarad and 3 microfarad, they are in series. The effective is 2 microfarad. So the equivalent circuit is A 6 microfarad. This is 1 microfarad. Then this is 2 microfarad. This 2 microfarad and 1 microfarad, they are parallel. So the effective is 3 microfarad. So the equivalent circuit is 6 microfarad A point, then 3 microfarad. This is B point. This 6 microfarad and 3 microfarad, they are in series. So the effective capacitance is 2 microfarad. This series continues to infinity. Let C microfarad is the effective capacitance between A and B. Let C microfarad is effective capacitance between A and B. If we hide this part, then what will be visible? This is identical with the previous circuit. So between this point and this point, the total capacitance is C microfarad. Between this point and this point, what is visible? That is C microfarad. This is C microfarad. If the left hidden part is visible, then it will look like this. The circuit will look like this is C microfarad. The total effective capacitance between A and B, the effective capacitance between A and B is C microfarad. Hence, this 1 microfarad, C microfarad, they are in parallel. The total is now C plus 1 microfarad. This is in series with 2 microfarad. The total is C microfarad between A and B. So we write it C microfarad equal to 1 by 2 microfarad plus 1 by C plus 1 microfarad. This implies C is equal to 2 into C plus 1 divided by C plus 3. This implies C square plus 3C equal to 2C plus 2. So this implies C square plus C minus 2, 0. This implies C is equal to minus 1 plus or minus root over 1 plus 8 by 2. So this implies C equal to minus 1 plus or minus 3 by 2. So the answer is 1. Other answer is negative, will not take. Hence the effective capacitance is 1 microfarad. Solve this circuit by taking C1 is 4 microfarad. C1 is 4 microfarad. A parallel plate capacitor consisting of two metal plates, each of area A, separated by distance d, filled with different dielectrics as shown in the figures. Find the capacitance in each case between A and B. The dielectric constant are K1, K2, etc. So this is a dielectric constant, this is a dielectric constant. Similarly, these are the dielectric constants. This is a dielectric, this is another dielectric. This dielectric constant is K1, this dielectric constant is K2, its thickness d by 2, its thickness d by 2. We can cut the capacitor at this line and we can detach the two parts. So the figure will be like this. So this is not same as the previous capacitor, so we have to join them either directly or indirectly. Let us join them by a wire. So this is a capacitor of capacitance C1, this is a capacitor of capacitance C2, they are connected in series. The C1 is K1 epsilon 0 A by D by 2. Similarly, C2 is equal to K2 epsilon 0 A by D by 2. Then C equal to series combination. So C1 C2 by C1 plus C2 or 1 by C1 plus 1 by C2. So this is equal to 1 by D by 2 K1 epsilon 0 A plus d by 2k2 epsilon 0 a. So this is equal to 1 by the LCM is twice k1 k2 epsilon 0 a, then this term is k2 plus k1. So the result is 2 k1 k2 epsilon 0 a by d into k1 plus k2. To find the capacitance, let us quote the capacitor along this line and detach the two parts. The two parts will look like this is the left part, this is the right part. This arrangement is not same as earlier, so we have to join the two parts either directly or indirectly. Let us join indirectly by connecting wires. This point is A, this point is B. The left capacitor capacitance C1, the right capacitor capacitance C3. This C1 and C3, they are connected in parallel. C1 is K1 epsilon 0 A by 2 by D. C3 is K3 epsilon 0 A by 2 by D. The effective capacitance is C equal to C1 plus C3. So this is equal to epsilon 0 A by 2D common, then K1 plus K3. To find the capacitance, we got along this line and along this line. Now it is the combination of three capacitors. This is the first capacitance, capacitance C1. This is the third capacitance, capacitance C3. This is the second capacitance C2. Then we have to join them. This is B point, this is A point. C1 C3 in parallel, then the result is in series with C2. C1 is K1 epsilon 0 A by 2 by D by 2. C3 is K3 epsilon 0 A by 2 by D by 2. C2 is K2 epsilon 0 A by D by 2. Then the effective capacitance is 1 by C3, 1 by C2 plus 1 by C1 plus C3. Then putting This C1, C3, C2. In this equation, we can find C. To find the capacitance, we cut along this line and along this line and detach the system. So this capacitance is C1, this capacitance is C3, this capacitance is C2. Then we have to join them. This point is A, this point is B. C2, C3 in series. The result is in parallel with C1. C1 is K1 epsilon 0 A by 2 by D. C3 is K3 epsilon 0 A by 2 by D by 2. C2 is K2 epsilon 0 A by 2 by D by 2. Putting these values, we find the effective capacitance is C equal to C1 plus 1 by C2 plus 1 by C3. In this equation, if we put this C1, C2, C3, then we will get the result. You try to solve the capacitance of this capacitor by yourself.